Hello, everyone. I hope you had a great lunch. Like Tobias just told you, I'm going to be talking to you about the DRY principle. But before we talk about the DRY principle, a bit about myself. Like he mentioned, I'm a senior software engineer at Pivotal Labs in New York City. We are an agile and lean consultancy. We work with clients to help them build web applications while learning agile principles. I've been in the software industry since 2007, working in a number of industries, everything from music publishing to finance to even healthcare. And my experiences really informed why I want to talk to you about the DRY principle today. You can check me out on Medium. I'm writing a fair bit right now. So let's talk about the DRY principle. You are all probably familiar with this phrase, the do not repeat yourself principle. In fact, it's probably the first thing you teach your newer engineers. Clean up your code, don't have duplication. But I want to give the original perspective on this, and I want to do it by telling you a story of a small application team. They were building a grocery store application that was responsible for determining the correct pricing that a store wanted to achieve while they were, for the different types of products that they're selling. Excuse me. So when I say an agile team, they were made up of a designer, a PM, and a few engineers, and they were working in iterations. So in the early stage of the application, there were 3 different types of products that were being sold. There was produce, meat, and dry goods, each of which had their own price margin that the store was targeting as a baseline. So they wanted to make sure they were at least getting this price margin for the different types of things. So I want to show you the code for all 3 of those classes. The first one is produce. You'll notice I've highlighted the margin. The next one I want to show you is dry good. And the last one I want to show you is meats. And you're probably thinking to yourself, that's a mess. There's duplication there. You should clean that up. And the grocery store team thought the same thing. So they got back together. They had a meeting. They decided that we need to do something about these 3 different types of products we're selling. We need to get rid of the code duplication that we see, and so we can keep moving forward. So the thing that they did was they went and they looked at these 3 classes, and they noticed the different types of duplication that they had, and they extracted it. And they extracted it into a mix-in. Do I have a lot of Rubyists? Raise your hand if you're a Rubyist. OK, so a mix-in is a way to provide multiple inheritance in Ruby. You can either use a mix-in to provide instance methods or class methods. It's a lot fancier than it sounds. I'm sorry, it's a lot less fancy than it sounds. So all you do to use this mix-in is a simple include statement. So that'll take all of those price methods that you saw earlier and add them to every instance of these 3 classes. There's no shared logic between them. It happens at runtime. So I'll give you a look at the priceable again. Notice that price is a function of how much it costs the store, the price margin, and then the whole thing is converted into a psychological price point. So the team introduced this abstraction, and they continued to deliver user stories. But something strange started happening over time. With each passing iteration, they noticed bugs were creeping into their backlog. And all of these bugs were centered around the different types of pricing that they were introducing. Until they got to a breaking point where they realized that they were in the midst of a mess. The mess that they were in was priceable. Over the iterations, priceable had become this unwieldy, horrible thing that every time you touched it, it introduced more bugs into the backlog. You probably have something like this in your system now. And it's probably way more complex than I could probably fit on 10 slides. And just like the grocery store team, you're probably wondering, how did this happen? How did we go from a good abstraction where we followed good principles to a mess? And the thrust of this talk is really about the dry principle, and that it actually has nothing to do with duplicate code. And you might be wondering to yourself, well, who's Steve to say this? Well, I'm not going to say it. I'm going to let the guys who came up with the dry principle say it. So Dave Thomas and Andy Hunt, the writers of The Pragmatic Programmer, in the original definition of the dry principle in their book, Pragmatic Programmer, is that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. Whew. That is a sentence, especially after a big lunch. But the key takeaway here is that every piece of knowledge must exist once and clearly. I want to reset back to kind of the context. We just talked about that Dave Thomas and Andy Hunt, the guys who came up with the dry principle, were really the ones to say that the dry principle is about not duplicating knowledge in your system. They don't mention duplicating code. And with that said, I was going to give you 3 techniques to identify premature abstractions in your system. The first of which is talking to your product team. So we often sit on teams as an agile, I work on multiple teams as a consultant. You probably work on just your team. As part of an agile team, we often have multiple roles. Each of these different people have different languages they speak, just as a side effect, naturally, of their different types of work. Business folks speak a business language, your domain. Engineers speak some specific abstractions that they've come up with on your project, and designers tend to speak the language of your users. Anytime that you have different people with different concerns working together, they just naturally devolve into their own languages. And we want to seek this place where everyone is speaking the same language so that we can stop the impedance mismatch of translating the requirements that are in business terms into the structures that are in the code. This is a very common idea. You've heard of domain-driven design. This is about getting to that place. And extreme programming also talks about this idea as a ubiquitous language, the language that the whole team speaks. So that's where we want to get to. And really, the only way to build alignment is to continue to have those conversations and notice those moments when words don't seem to mean the same thing to the person you're talking to. So the grocery store team did that. They got up and they drew the business structures that were in the grocery store application on the whiteboard. They drew the event that was coming into the system. We want to price something. And the engineers were the only ones who could tell where that message actually goes. And it goes to priceable. And dry goods, produce, and meats simply use that, that behavior. So you see all the coupling is in on priceable. Those 3 things, dry goods, produce, and meats, can't change independently of changes to priceable. So this was a giant smell. Engineers had to explain what a priceable thing was to your product people, and they don't have a word for that. And that this is a context moment. In context of your team, you now can either decide as a team to adopt priceable into the domain language, or make the decision that priceable is an abstraction that should not exist. So in the context for this team, they decided that priceable shouldn't exist. So they have to get rid of it from the code as well. So that's one technique you can use to identify that priceable is a premature abstraction. Here's just a little bit more about what we've actually done here is we've taken dry goods, produce, and meats, and they meant one thing to the designer and the PM, and they meant significantly less to the engineers. In fact, all the understanding and business logic around pricing things was built up in this priceable object that only the engineers even knew existed. So we decided to get rid of that and bring alignment. So now these three different types of products all mean the same thing to everyone on our team. So that's the technique of talking to our product people. The next technique, if for some reason you can't speak to your product team, maybe you don't have one or their time is in such short supply because they're managing other projects, you can use the next two techniques as a fallback. The first of those next two techniques, if that's not confusing enough, is bits versus clumps. Kent Beck proposed this idea in an article he wrote on Facebook. Does everyone know who Kent Beck is? Seeing a lot of nods. He's the guy who came up with test-driven development and also is a big advocate of software design. So he wrote this article. He gave you two questions that you could ask about any design in your system. The first of which is, can I reason about these things separately? So as an engineer on the grocery store team, if we were to look at two of the different types of products, dry goods or produce, and say, can I reason about produce and dry goods independently? And the only way we can tell that is looking at our context and our backlog. And so if we were to do that for this team, what we would discover is that produce has a bunch of changes upcoming. Specifically, that produce is about to change to cost more when a piece of produce is out of season. And dry good does not have any such change coming up. So we see this whole slew of changes that are about to only affect one type of entity for us that doesn't affect the other. So it's a hint that these things are not related. So the answer to, can I reason about them separately, is yes. The next question Kent tells us to ask is, are they structurally separate? And if they're not, we have to do something about it. And as we've already seen, they're not structurally separate. They all depend on the same thing. So we actually have to get rid of priceable and separate these things so they can change at a different rate. That's bits versus clumps. There's a link in there. You'll be able to get access to that article once we send out the slides. The last technique I want to show you is noticing divergent change. Does everyone know what a code smell is? We're probably definitely all familiar with shotgun surgery then. This is the one that I always hear about. Shotgun surgery, for the sake of reiteration, is changing multiple places in your system for the same reason. Here you see three classes, each of which have a margin using a floating point value. We all know the horribleness of using floating point math to calculate prices. So we want to change those in our system to use big decimal. This is an example of shotgun surgery. That idea is spread throughout the entire system, so we have to change all of the classes that have math. But there's another code smell that I actually don't hear talked about much. It's divergent change. It's the polar opposite of shotgun surgery. Instead of changing many places for one reason, divergent change is a code smell about changing one place for many reasons. So here you see the first iteration of priceable. And then a story comes in that we have to price steaks based on cut. So we have to change the code. And then a second story comes through that produce should be based on season. So now we've changed this code for three different disparate reasons. And then we can get into this place where it's a mess. This is divergent change. And these things live on a continuum. On one side, we have shotgun surgery telling us that we have too much duplication in our system. This is the very reason the dry principle exists. But if you overzealously apply it, you miss the other end of the spectrum, which is about not having enough separation in your code. You need to allow yourself to change the things you want it to change independently. So that's noticing divergent change. So I've given you 3 techniques: talking to your product team to suss out the domain language, asking yourself, can I reason about these ideas separately, and are they actually separate? And lastly, noticing the code smell of divergent change. All 3 of these things point to priceable as a premature abstraction. So I'm going to spend the rest of the talk showing you how you can step back from these premature abstractions. So what we're going to do is we're going to get rid of priceable, and we're going to do it by reintroducing code duplication. What we're going to do is we're going to remove the include statement that uses our mix-in. We're just going to delete that, and we're going to do what the runtime does and paste in the contents of priceable. So now we have all of the logic of the mix-in inside of our class. We can run our tests. We can know everything works. And now we need to do a separate thing. We have to completely remove everything that does not need to be there. So everything that doesn't have to do with pricing produce, delete it from the price method. And now we're isolated from our dependency on priceable. We're going to do the same thing for dry goods. Remove the mix-in include statement, copy paste its contents, run our tests, and then delete everything we don't need. This one's particularly nice. Look at all that junk we just got rid of. And lastly, we're going to do the same thing with meats. Remove the include statement, copy paste the contents, run our tests, and then lastly, delete everything that doesn't need to be there. So season's gone. And the best thing, hold on to your hats for this, we can get rid of priceable. Oh, I had a Thanos snap in there. I forgot I didn't have my up-to-date slides, so you have to imagine it. So here's the final version of these 3 classes. And we're now back to a point of safety where we can change these different products independently of one another, and we can get back to not having so many bugs about pricing in our backlog. You might be wondering to yourself, okay, the grocery store team got it wrong. Steve, there's even still some code duplication in there. That psychological price method still there. That's still code duplication. What's the right abstraction? And based on what we've talked about today, without examining the context, we don't have enough information. I see a lot of teams use refactoring tools to notice sort of duplication and shove things together. Now, you probably don't have code duplication that's this explicit. You probably have a bunch of things that look very similar, and teams get tempted to extract them. But this is a great moment to walk away. There's no correct abstraction here. That was the mistake the grocery store team made, not that they introduced the wrong abstraction. So in conclusion, we talked about the original meaning of the dry principle, which is about not duplicating ideas in your system. I gave you 3 techniques to identify premature abstractions that are a side effect of misapplying this principle, talking to your product team, the bits versus clump strategy, which is asking yourself, can I reason about this separately, and is it structurally separate? And lastly, I told you how to notice divergent change. Again, I really emphasize that you should favor talking to your product team over those later 2 strategies. And lastly, I showed you how to get back to a safe place by reintroducing code duplication. Not to mention, we had a nice fire drill break. Thank you very much. If you have any questions, I'd love to hear them now.
I know it's a simplified example, but I think what the team learned is that how to calculate the price required instance-specific knowledge, so like member data, for instance. But when you put those three, you could easily point out that how to do the psychological price did not require any instance-specific knowledge. So like that could be the opportunity to pull out, because there is one and only one way to calculate that psychological price.
For the moment.
Yeah.
So like, and this is why I was trying to emphasize as I went through that it's very context specific. Like there are other types of psychological price points now that people are playing with, like ending in 3-4, just to like break. People are so used to being tricked with the 9-9 thing now that you need to like trick them in other ways. So like that's an example of like if your marketing team wanted to play around with using 3-4, but we don't want to use it for meats yet because maybe that's a really big moneymaker for us. So like let's not play with that. But dry goods, sure, like that's a safe place. So like without the context of your team and what you're trying to achieve, you can get in trouble. But you are right. That instance variable did tie into it, but I've seen this same story play out on a much larger scale with, say, services, where people extracted out all of the sign-in flow, even though the user model was completely different. Any other questions? All right, thank you very much. Quick shameless plug. I am writing a book. It's on LeanPub, so that means it's not finished. You can check it out on leanpub.com/agile software. It's a software book with a story. So instead of isolating you from the context of applying agile software, this has a narrative and code examples, and you can see how interpersonal relationships are a key part to delivering software in an agile way. All right, thank you very much.